So the context graphs, I have a lot of videos about it, how they work, how they should work. Right now, it's a bit hypish topic because main idea of the context graph is the decision traces, but main purpose of the context graph that agent could learn from the past decisions. And to achieve this goal, actually, we need much more than the single graph. We need the combination of two crucial things, actually. Um, One thing actually is the not just the graph, but the agentic memory, and especially what we usually call mimicking people, the episodic memory, where we focus on the events and consequences of events, and usually is the area of the causal analysis and temporal analysis. So it's a temporal causality. And another thing that to achieve the learning, we actually need um, self-reflection loop when the agent analyze his actions and take the information from the causality graph and then make the learning. Actually, it's the possible architecture, but to achieve this, we need temporal aware memory. And temporal aware memory, actually, that's the topic of my book that nearly finished. Only one thing that I haven't finished yet, and I haven't made my opinion. Should we design a memory as the human one, or should we invent our own memory that are more sophisticated? It's the open question, and I also want to, in my book, explain a bit how the human memory works. And to do it properly, it's a lot of materials there. But the intention of the context graph are right. But we see it oversimplified because it's not one graph, it's a multiple graph, or it's multi-layered graph or multi-layered network where you have causality and temporal awareness and also temporal causal relations. They sound similar, but they do completely different analysis. And also, when we're talking about the memory and reflection loop, we could talk about the concept of the cognitive processes. Cognitive processes are really important. So you have the incoming information, and it's not processed immediately in your brain. So you have some kind of ingestion pipeline. And the last step of this ingestion pipeline happens when you sleep, and the memory is transferred from this operational temporal memory to the permanent one. And that's the main point where the schematization happens and all the things. And also, your memory is extremely complex because when you try to recall something, this is the active process of the reconstruction, and for sure the agents doesn't have such complex recall. We could say that agent could have the context formation actually that could somehow mimic the recall, but it's a separate question. But really important thing that you have um, this cognitive process that analyze the memory and especially the event-based memory. And we also have the cognitive process that scan your action log. And action log, we could not say that it's a working on operational memory or some kind of working on operational memory, but extended one, because the agent should remember everything that he did and criticize what he currently doing. and that's the main idea of the architecture of the better context and self-learning on own actions. Um, you are all sorry, I still feel sick. And also quite a useful topic in a context of the cellular learning and decision traces actually could be the work of Mark with the promise theory. Because instead of actions, we need to think in promises, because action is something that you made. The promise is something that you promise and maybe you haven't made it by some reasons. So that's why the promises are more flexible in terms of the action log, because we need to see it much broader, right? So instead of tracking the events of actions and consequences of actions, we need to see the graph of the promises, the asks of others, the influence of agent to agent interaction, and then all these things contribute to your actions, and then you could analyze the actions together with the promises and external influence. And then we could say that we have the cascade of signals, and the signals could be the ask from others, from the users, from the agents. Then some signals could be the additional information that help you to make the decisions. And then all the signals converted to some form of promises of you and promises of others, and then you have the promise graph, and from the promise graph some of them materialized as actions, and these actions and transitions from the promises to actions form the layer of the decision traces, and then the promises, actions, and decisions actually form some kind of lock and casual event graph that could be used in the future for better decisions. So somehow it's proposed architecture of how it could work. But all this actually, it's not the pure graph. We don't need to do the pure graph for this. Actually, we have the multi-layered network structure that could have some data in a relational form, some data in a time series form, some denormalization of the data that allow us to apply the casual, temporal, casual, maybe even some topology analysis, because the temporal causality quite well working with the topology and persistent topology analysis and all other things. But all this should have the solid base of agentic memory, and I really focus in my book exactly on the agentic memory with the casual and temporal context. So I really recommend you to give it a try, to buy the book, even if it's 85 or 90% ready. I promise you that if you buy from the Learn Pub, you will get the updates constantly, and it's a live product that never stops. I always try to add something to the topic if I see that it's an interesting material there. Give it a try, and try to think about the context graph as not as a graph, but the purpose of the learning and making the better decisions. And to make the better decisions, you need much more than graph. You need to have complex memory with the set of the cognitive processes, and the cognitive processing is even more important than the persistent layer and the structure of the data inside your memory. See you next time. Choose.